Hello and welcome to a Maths with Harry lesson. In this video, we're going to be having a look at solving linear inequalities. Now, you probably have seen inequalities before, but I'm going to introduce you to the four inequalities. There's four signs that kind of look like crocodiles that you've probably seen at GCSE and maybe even at primary school as well. They are less than, greater than, less than or equal to, and greater than or equal to. Four signs that we can use to kind of create a set of numbers. So let's have a look at four examples, and the four examples are where x is an integer, okay? When I say something like x is, and in this case we'll say less than 10, if x is an integer, what I mean is x being the set, and we can have, well, it's less than 10, not equal to 10, so they're all integers, 9, 8, 7, 6, 5, 4, and that can just carry on all the way down to negative infinity. We're just going to get less and less, smaller, less and less negative, aren't we? Okay? Or more and more negative, sorry. We're going to get less bigger. So we're going in this set here, and these curly brackets, by the way, just denote a set. We're going to have the set 9, 8, 7, 6, all the way down to, well, minus 10, minus 11, all the way down to negative infinity. So hopefully that's something you can get your head round. X is less than 10 is this set here, all the way down to negative infinity. If x, let's say, is greater than, I don't know, let's say 9, then what we want is all the numbers that are integers greater than 9. So x, in this case, will be the set 10, 11, 12, 13, and that again will carry on, but not to negative infinity here because we're not getting smaller each time. We're getting bigger because it's all x greater than 9. So in this case, it's going to go to infinity, positive infinity to be precise. Okay, but don't worry too much about that. We're just wanting to understand these signs here. Let's say if we've got, well, let's have a look at less than or equal to 10. What's going to change about this set here? Well, the only difference is we can now be equal to 10. So it's going to be the set 10, 9, 8, 7, and that can carry on down to negative infinity. And let's have a look greater than or equal to 9. That can be greater than or equal to 9 can be 9, 10, 11, 12, and so on, okay? So those are our sort of four inequalities: less than, greater than, less than or equal to, and greater than or equal to. Now in this video, we're going to have a look at solving linear inequalities. You probably have done this before at GCSE, but it comes up again at A-level, and you need to be able to do it. So, first of all, we have to think, what does it mean to solve a linear inequality? We know what it means to solve a linear equation. An equation, for example, being 2x plus 1 is equal to 10. We know what that means. We're trying to find the value of x that we can substitute into here to get 10, okay? Well, we can solve that. We can say 2x is 9, so x is 4.5, or 9 over 2. We can see then, if we substitute 9 over 2 into there, we're going to get 10 on both sides. So we understand what it means to solve a linear equation, but what does it mean to solve a linear inequality? Well, the solution to a linear inequality is the something of all real numbers that makes the inequality true. And the something that goes here is the set. It's the set of all real numbers. Don't worry too much about the numbers being real. It's just the set of all the numbers we can substitute into our inequality to make that inequality true. So for example, if we have a look here, this is a linear equation. It's like an example I've just solved. We can substitute here x is equal to minus 1 to get minus 2 plus 3, which is 1. So that solves our equation. There's one value to a linear equation that makes that true. Any other value of x doesn't work. We don't get 1 on the left-hand side. But if we compare that to a linear inequality, there's two examples here. It was equal to 1 for the equation, but it's less than 1 here. 2x plus 3 is less than 1. That's what makes it an inequality, because right a minute ago, we just had a look right at the start. These were our 4 inequalities. So that's one example. And what we're saying here is, what are the values of x that makes 2x plus 3 less than 1? Another example, here we've got greater than or equal to. This case, we're saying what values of x can we substitute to make 2x plus 3 greater or equal to 1? Okay, so those are some examples. So let's actually have a go at solving some now, and surprise, surprise, we just solved them exactly like we solved them with linear equations. So I encourage you to pause and have a go, and then we'll work through them quite quickly because they're not too hard to solve. Okay, hopefully you've had a go. Let's see if your answers are correct. We've got x on both sides here, on the left and the right hand side for part A. So what I'm going to do is I'm going to take this x over to this side. So I'm going to get that being equal, or we can use an arrow, to 4x plus 9 is less than or equal to 20. Okay, then what I'm going to do is I'm going to minus 9, so that will tell me that 4x is, did I say less than? I meant greater than or equal to. Greater than or equal to 11. Sometimes I write down the right thing, but I say the wrong thing. It's greater than or equal to. So I just minus 9 from both sides there. And then, just like in an equation, I'm going to divide both sides by 4. So when I do that, I'll get x is greater than 11 over 4. And that is my final answer for x. Now remember, we want the set of values here. The set of values means that if I substitute x being 11 over 4 or anything greater than that, both sides of the inequality here will be, well, the right hand side will be greater than the left hand side, or it could be equal to. It will be equal to if we substitute 11 over 4 in. Okay, so anything greater than 11 over 4 means that the left-hand side is greater than the right-hand side. Both the left and the right-hand side work for this inequality. Okay, so we've got a set of values here. Not just one value, we've got an infinitely many number of x's we can substitute in here. Anything greater than or equal to 11 over 4 will satisfy our inequality. Okay, right, part B. It's actually not as complicated as part A. I'm going to add 3x to both sides. So I'm going to get 12 is less than 3x plus 27. And then I'm going to get, minus 27 from both sides. Minus 15 is less than 3x. And then I've got my x on the right-hand side. I want my x on the left-hand side. What I could have done really is minus 12x from, just minus 12, sorry, no x, just minus 12 from both sides, and my 3x would have stayed there, but it doesn't really matter. I wanted to get rid of the negative. So what I'm going to do is I'm going to write that like that, and hopefully you can see why that is the case. We've got the open side of the inequality here on with the 3x. We're saying minus 15 is less than 3x. So if we write that the other way, the inequality needs to flip. 3x is greater than minus 15. And then what I can do is I can just divide by 3 to give me x is greater than minus 5. Okay? And that is our answer to B. And again, it's a set. It's all of the values of x that are greater than minus 5. Makes 12 minus 3x less than 27. And check it. If you put minus 6 into there, this inequality will not hold, because minus 6 is not greater than minus 5. But if you put in maybe minus 4, or if you put in 10, or anything greater than minus 5, we will know that 12 minus 3x will be less than 27. Okay, let's have a look at C then. We just need to expand our brackets first, so I'm going to put a little arrow to show my working. We'll end up with 3x minus 15 is greater than 5 minus 2x plus 16. Okay, then what I'm going to do is I'm going to get x on the same side. I'm going to add 2x to both sides to get rid of this minus 2 here. So we'll have 5x minus 15, and I'm also going to simplify, or did I take it, oh no, okay, no, we'll take it over, actually like I've done in my solution. I'm also going to take over the minus 5 from both sides, take over the 5 by minusing it, so we'll end up with this. Hopefully that makes sense there. Okay, we could have added those together as well, but what I'm working with here, I took the 5 over to give me minus 20. And then if I add 20 to both sides, I will get that. 5x is greater than 36. 36, of course, does not go into 5, or 5 does not go into 36. So x will be greater than 36 over 5. And again, it's a fraction. It's saying all values of x that are greater than 36 over 5 will satisfy this inequality. It will mean 3 times x minus 5 is greater than 5 minus 2 all times x minus 3. Okay, right. What happens now if we've got two inequalities together? So there we just had this inequality. Here we just had this inequality, and we just needed our set of values for x that satisfy that. What happens, for example, if we've got two inequalities together? So my example here is, well, x is greater than 2 and x is less than or equal to 5. So what I need to do is kind of find the values that satisfy both of them. And we can see that it's important here, the wording. We've got x is greater than 2 and it is also less than or equal to 5. A number line comes in really useful here. You've probably seen these at GCSE. But what I'm going to do is I'm going to put on, first of all, x being greater than 2. X being greater than 2 looks something like that. I have here an open circle. We've not filled the circle in, and that's because we've got no equal sign on the inequality. So we're going to put an open circle and then an arrow pointing this way, because those are all the numbers that are greater than 2. Okay, now the green is less than or equal to 5, so if I move this where we need it to be, less than or equal to 5, and in fact we need to take the arrow with it, so I'll take it all. Less than or equal to 5 will be there. Okay, now I've just put this green one above the number arrow, or the number line, sorry, so that it looks quite nice. Here we've filled the circle in because we've got an equal to, so we've got a closed circle. And our arrow's pointing this way because it's x being less than or equal to 5. Now what we want is the values that satisfy both inequalities. And if I draw a grade dashed line down there and there, we can see that this part of the green inequality and that part of the red inequality is the only parts where the number line is satisfied in both inequalities. Here and here, we can see that, okay? So what we want is the set that is represented by these two grey lines. We can't be equal to 2, but we can be equal to 5. So we're going to have 2 and 5, okay? And then I need some x in the middle. I need my x to be in the middle. So what I need is, I need x to be between 2 and 5, not equal to 2, but equal to 5. So I'm going to put those values in there. What that is saying, and you've probably seen this kind of merged inequality, is it's saying 2 is less than x, and x is less than or equal to 5. And that's exactly true, because we can see x here, we can be equal to, we can see 5 here, we can be equal to 5, but we can't be equal to 2, and we need to be in between, so that is our merged inequality. Okay, now we want just to slightly introduce a little bit of set notation. I introduced it at the start, but I'm going to introduce it again here. Okay, I've got two examples. This example is what we just wrote above here. So 2 is less than x is less than or equal to 5. That is exactly this here. We've just kind of simplified that. Okay, now in set notation, we write that with curly brackets. We saw that above the curly brackets here. right at the start, these were our curly brackets. They denote a set. If we write it in set notation, what we want is, well, we want x, so I'm going to write x, and then the inequality that we're dealing with. So 2 is less than x, which is less than or equal to 5, and close your curly brackets, okay? So that's those two inequalities written in set notation. Now note here that was an and. This example in set notation, we're using or. So what that's saying is x is less than or equal to -1, or x is greater than 3. Now it doesn't make sense, if you think about this, to be an and, because something cannot be less than or equal to 1 and greater than 3 at the same time. So it's got to be an or here. And if we think about that in set notation, we will have, well, x, because that's the variable that we've got, x less than or equal to -1, and I can't put this in the same curly bracket because it's not an and. It doesn't make sense for it to be an and. So we're going to have that set united, so we're going to use a union symbol here. You might remember this from maybe probability or your diagrams, your Venn diagrams, you might remember this. It's going to be that set union with this set, x, where x is greater than 3, okay? And the colon here, I say as such that. We've got x such that this inequality holds. And that is how we merge two inequalities together that is either an and, like that, or an or, like that. Okay, so let's have a look at the final example for this video. What we want to do is we want to use set notation to describe the set of values for x for which this inequality and this inequality hold, and here this inequality or this inequality hold. Okay, so press pause and have a go if you want to, and then we'll work through the answer. Don't worry if you didn't pause, do not fear, we'll go through it right now. It is a little tricky when you first do this. So, all we want to do, the method really, is to solve both inequalities. So we can do that quite quickly. We can say 3x here will be less than or equal to 12 by minusing 8 from both sides, and then dividing by x, x will be less than or equal to 4. So I'm going to highlight that in grey because that solves this inequality here. Now in red, I'm going to solve this inequality. So what I'm going to do is expand the bracket to give me 6x minus 14 is greater than or equal to x plus 6. Then I'm going to add 14 to both sides and also minus x from both sides to give me 5x is greater than or equal to 20. Okay? Pause if you can't see where that's come from and just have a look at the steps that I've done sort of in one there. Then I'm going to divide by 5 to give me x is greater than or equal to 4. So in red, we'll highlight that because they correspond together. So what I've done is I've solved this inequality to give me this set of values, solved this inequality to give me this set of values. And then we've got an and. So we need to combine these two together. X must be greater than 4 and less than, so less than or equal to 4. And at the same time, x must be greater than or equal to 4. So because we've got an and there, merging those together, that tells me that x must be equal to 4. Because for those to be working together, this and this means that x must be equal to 4. So that is our answer. Now in this case we had two inequalities, but then we got an equals, and that's fine because we merged these two inequalities together. Okay, so that's our and example. Here is our or example, and in fact we wanted to put that in set notation, didn't we? So in set notation, that is x such that x is equal to 4. It's that set like that. Or it's just the set containing 4. Okay, those are also your answers. Okay, B, what we want to do is solve each inequality, and we'll do this quite quickly. We'll get dividing by 4 both sides. 3x plus 7 is less than or equal to 5. And then we will have 3x is less than or equal to minus 2. So x will be less than or equal to minus 2 over 3. And solving this one, what we're going to get is we can, well, what did I do here? I'm just having a look. I divided by 2 both sides to give me 3x minus 5 is greater than 7 minus 6x over 4. Then multiplied by 4 to give me 12x minus 20 is greater than or equal to 7 minus 6x. Then what I did is I added 6x to both sides, and I can take off, or add, sorry, the 20 to both sides to give me that. And that tells me x is greater than or equal to 27 over 18, which is equal to 3 over 2. So what I've got is I've got this case here from there, and I've then got this case here from that, or that inequality gives me that set of solutions. So x is less than or equal to minus 2 over 3, or x is greater than or equal to 3 over 2, okay? Just simplifying that fraction there. So it's an or, so we just need to write them as set notation, so it will be this. X such that x is less than or equal to minus 2 over 3, or, so union, this set, x such that x is greater than or equal to 3 over 2. And that there is our final answer in set notation. So hopefully now you know what the 4 inequalities are, and you can solve inequalities and solve them with set notation.